Hello, my name is John Cody. In this video, I'll be talking about universal hyperbolic geometry, specifically the quadria of a projective quadrangle and the quadreal of a projective quadrilateral. In the subject of universal hyperbolic geometry, it treats geometry as being really about formulas. It's a metrical algebraic geometry, where it's a geometry looked at algebraically with a metrical approach where we are interested in making measurements. Okay, so we take the point of view that the geometry is divided into two halves. There's affine geometry and projective geometry. And under affine geometry, we have the framework of rational trigonometry, an algebraic framework called rational trigonometry. And in projective geometry, there is a framework of universal hyperbolic geometry and elliptic or spherical geometry. And so we have the two halves of the subject, the affine geometry and the projective geometry, and we have formulas that have been discovered for these geometries in both affine geometry and projective geometry. And the formulas are the quadrants between points, the spread between lines. There are 9 main laws in the subject, 5 main laws in rational trigonometry, which are Pythagoras' theorem, the triple quad formula, the spread law, and the cross law, and the triple spread formula. And in projective geometry, we have also have formulas for Pythagoras' theorem, the triple quad formula, the spread law, and the cross law. I'll provide a link here to a video that details these 9 formulas in geometry. They're like the 9 main formulas in the subject. Also, we have a metrical notion of quadria of a triangle in both affine geometry and projective geometry. And also in projective geometry, we have a notion of the dual of a triangle, with a metrical notion of a quantity called the quadreal of a trilateral. So there's a duality between a triangle and a trilateral in projective geometry. In affine geometry, we have a notion of a quadria of a quadrilateral. That's a metrical measurement of a quadrilateral. And in projective geometry, we have what's called the quadria of a quadrangle, and also there's a dual formula, the quadreal of a quadrilateral in projective geometry. So in projective geometry, the triangle has a dual, which is the trilateral, and the quadrangle has a dual, which is a quadrilateral. The main reference for universal hyperbolic geometry, or for projective geometry, is this paper, Universal Hyperbolic Geometry 1 Trigonometry. And I'll provide another link here to, or at the end of the video in the description, I'll provide links to other references for affine geometry, rational trigonometry, and some references for universal hyperbolic geometry. Okay, so we have here a diagram consisting of projective points. Well, this shape here is a quadrangle consisting of projective points A1, A2, A3, and A4. We have this metrical notion of a quadrants between points. So Q1 is the quadrants between A1 and A2. Q2 is the quadrants between A2 and A3. Q3 is the quadrants between A3 and A4. And Q4 is the quadrants between A4 and A1. S1 is the spread between line A1, A2 and the line formed by A1 and A4. And similarly, S2 is the spread between the lines formed by the points A1, A2 and A2, A3, and S3 is the spread between lines A2, A3 and A3, A4, and S4 is the spread between lines A3, A4 and A4, A1. And there's this quantity A, projectively invariant quantity A, called the quadria of a projective quadrangle. So this is the projective quadrangle. And over here, we have this dual notion of a projective quadrilateral consisting of same 4 points, but we have these lines. Quadrilateral has the lines A1, A2, the line A2, A3, the line A3, A4, the line A4, A1, and this projectively invariant quantity is called L. It's the quadreal of the projective quadrilateral. Okay, so I'll now present the main formula for the quadria of a projective quadrangle. So here's our projective quadrangle. 1 and 2, they're triangulated 2 different ways. So this one has a chord between A1 and A3, and this diagram too has a chord between A2 and A4, and it triangulates it into there's 2 separate triangles here. So we have triangle A1, A2, A3, and the other triangle is A1, A3, A4. And in this diagram, the quadrangle has been triangulated into triangles A1, A2, A4, and triangle A2, A3, A4. Okay, so I'm just going to hand you what the formula is for the quadria of a projective quadrangle. It's this formula right here. So the quadria A of the projective quadrangle is a quadratic formula. So it's given as A minus Q1 times Q2 times S2 minus Q3 times Q4 times S4, all of that squared is equal to 4 times Q1 times Q2 times Q3 times Q4 times 1 minus S1 times 1 minus S3. That's equation 1. It goes with this triangulation. And the other formula is A minus, it is also a quadratic formula, and it goes with this triangulation over here. And the formula is A minus Q1, Q4, S1 minus Q2, Q3, S3, all of that squared is equal to 4 times Q1 times Q2 times Q3 times Q4 times 1 minus S2 times 1 minus S4. So we have 2 quadratic equations for the different triangulations, and they have a common solution A. So it's been worked out in a separate video that these 2 quadratic equations are compatible, meaning they have a common solution A, and when you work out the formula for that common solution, it's given right here. Works out to this quantity. A is equal to Q1 times Q2 times S2 plus Q3 times Q4 times S4 plus Q1 times Q4 times S1 plus Q2 times Q3 times S3, all divided by 2, minus 4 times Q1 times Q2 times Q3 times Q4 times 1 minus S1 times 1 minus S3 minus 1 minus S2 times 1 minus S4. All of that divided by 2 times, in brackets, Q1 times Q2 times S2 plus Q3 times Q4 times S4 minus Q1 times Q4 times S1 minus Q2 times Q3 minus times S3. Okay, so this is the common solution to these 2 quadratic equations, 1 and 2, and you'll notice that there is no square root symbol involved in this at all. So we're getting the solution of a quadratic equation without any square roots. Okay, so next I'm going to talk about the triangulation of the quadrilateral for the quadrilateral equations. So here we have, so we're going to be talking about the quadria of the projective quadrilateral now, and looking at two different triangulations of this. So the first triangulation is figure 3, and here's our quadrilateral shape, and over here is figure 4, and it's the same quadrilateral, consisting of projective points A1, A2, A3, A4, and lines A1, A2, line A2, A3, line A3, A4, and line A4, A1. Okay, so it's just like the dual of the projective quadrangle. So this quantity L is the quadreal of the projective quadrilateral. It's another projectively invariant quantity. And here's the quadratic equation that goes with this triangulation is L minus S2, S3, Q2 minus S1, S4, Q4. So this S2, S3, Q2 is the quadreal of this projective triangle A2, A3, A7. So, and this quantity here, S2, S4, Q4, S1, S4, Q4, so S1, Q4, S4 is the quadreal of this projective trilateral A1, A7, A4. Okay, so again, equation 3 goes with this triangulation, and we have L minus S2, S3, Q2 minus S1, S4, Q4, all of that squared is equal to 4 times S1, S2, S3, S4 times 1 minus Q1 times 1 minus Q3. And similarly, the second quadratic equation is for this triangulation. We have L minus S1, S2, Q1. So S1, S2, Q1 is the quadreal of the trilateral A1, A2, A6 minus S3, S4, Q3. S3, S4, Q3 is the quadreal of the trilateral A3, A4, A6. So we have L minus S1, S2, Q1 minus S2, S4, Q3. All of that squared is equal to 4 times S1 times S2 times S3 times S4 times 1 minus Q2 times 1 minus Q4. And just like in the quadrangle case, these two quadratic equations are compatible, meaning they have a common solution for the quantity L, and that common solution is given here. The quadreal L of the projective quadrilateral is S2 times S3 times Q2 plus S1 times S4 times Q4 plus S1 times S2 times Q1 plus S3 times S4 times Q3, all divided by 2, minus 4 times S1, S2, S3 times S4 times 1 minus Q1 times 1 minus Q3 minus 1 minus Q2 times 1 minus Q4, closing brackets, all divided by 2 times, opening brackets, S2, S3, Q2 plus S1, S4, Q4 minus S1, S2, Q1 minus S3, S4, Q3. Okay, so we have given the formulas for the quadria of the projective quadrangle and the quadreal of the projective quadrilateral, and we have also shown what the triangulations are that go with those formulas. Okay, thank you for listening.